Going to work with this character leg that I've set up. It's kind of similar in some fashion to ones we've worked on recently. The idea being is that it has some very non-standard joints and components to it, and pieces that become very difficult to try and sort out how they're going to work. You can't just rig this as you would rig a human leg, for instance. Another thing I should point out with robot legs like this that I often see that are sent to us and said, hey, can you rig this for us, is they're simply not plausible and they don't work. For instance, they have no ankle joint and can't keep their foot flat on the ground no matter what they do. All the joints are planar, including the hip, so there's no way that the robot can place its weight distribution over its foot, so if it lifts a foot up, it's just going to fall over. Things of that nature, and it just doesn't look right. Essentially, the character needs to be designed properly. Even with a robot, it just can't be anything. It has to have proper design features. So what we're going to look at is just sort of what I have here and how this is going to become difficult. Looking at it from the front perspective, what we have is a leg system that has an offset pivot at the top, and I'll just align that. So this is a ball joint, be connected up to a hip, somewhere, and the robot would be falling off this point here. It would have some kind of ball joint hip here for the leg. The leg then goes down out on an angle, and that's going to cause our own little problem to deal with that and work with it. So next we look at it from the side. Here's that top pivot, and of course I guess really maybe the top might be the better way to look at it from off the bat. This section here, this whole section here, the whole leg has to be able to pivot around this on an offset, sort of in an offset way. It isn't like a hip joint in a human where it's sort of in line and things can be lined up. It's not going to be lined up. Going down from there, we have a very strange knee joint. This knee joint is a bendy, flexy knee joint. So right in here, these 4 red pieces can actually bend and flex. And we're going to pretend that it's all being driven off this piston that goes up and down, and actually has a motion that's going up and down for us. This in itself is going to become a problem because it's going to have multiple joints. Plus, it's going to be pivoting up at the top. And to make it even more difficult, as we get down to the bottom, we have 2 joints for an ankle. In this case, we've got a planar joint at the top here. This planar joint only rotates forward and backwards, so it's only actually going in a forward-backwards motion. It can't rotate side to side. So this is going to produce an issue right off the bat. How do we make this work in an ankle situation? Because if you think about it in an IK solution for a character, if you've ever rigged one, the ankle rotates around all axes, and this can't. So it's going to cause a problem. What we have right below to make it a plausible model and a plausible robot is an ankle joint that can rotate side to side and actually front and back as well. And it can actually handle some twist too if it has to around the 3rd axis and give us a little bit of flex in here so that we can get the foot into the positions that we're going to need to. And then for the foot, which is really actually quite easy, it's just going to be a flexible joint in between sort of a heel and a ball sort of the foot. So that won't be such a big deal really when it comes right down to it. Now to deal with this, again, modeling was sort of crucial in certain areas because the next thing we have to deal with not only is the piston, which is relatively easy to set up, but are going to be dealing with some of the hoses and whatnot that need to stretch and flex. Again, this comes back down to having proper models designed and built correctly. One of the problems I find is that I get these things sent to me and everything's been collapsed down to an edible poly. So I've got all these tubing pieces that might have been built from splines, and the splines have been collapsed out of them, so I don't even have the original path to work with and to be able to work with that to be able to drive it. That being said, I don't even like going that route. Even if I had the original spline and I could set up a spline IK type system with bones all the way down, bones sitting here all the way down the system, what I find is that we're going to get all kinds of stretching because I want to be able to drive this dynamically. So in other words, I want to have it be able to bend and flex dynamically using the flex modifier we're going to use. So as the character walks, we have a little bit of sort of jiggle in those in the tubing. Now what'll happen with that is that if we do it with bones and I flex any one of the joints, if I were to take this one joint here and flex it up and down, for instance, it's making the one below it shorter or longer and the top one shorter or longer, and it's going to actually make the tubing sort of, do an accordion style action. I don't think that'll look very good. I think we'd want the whole thing just to sort of wobble and wiggle, but keep its length the best it can, and try and keep its shape and not have pieces of it sort of accordioning up and in and out of it. We want to kind of consider it a fairly rigid piece of sort of rubber tubing of some kind, so that it'll work correctly. So what I've done is I've taken a different route. I'm just going to turn off the path deform. Take a look at how it's been modeled here. Just clear my drawing. And you'll see that essentially what we have is a straight model. And it's being path deformed into place. So to do this, I started with a cylinder. I did it really quick and easy to be able to propagate it. An X-form just to do a bit of shaping to it. An edit poly where I was taking each segment and I was propagating it and adding it to it. I'll just say parent here. So I could actually make the whole thing longer just by copying out a piece and cloning it to an element. While I was working, I wanted to be seeing the end result each time, and you'll notice that what's going to happen is I'm not going to be seeing the end result very well if I don't have the poly select in there that's actually turning it on. Here, I'll just try and show that again, sorry. So now I can actually work with no selection. If I get rid of the poly select, you'll see that as I select pieces, they get put onto the path deform. The poly select is in there just to terminate the selection while I work with it, so that we're not seeing it in there. So it isn't needed at the end result. And then a path deform, and I've picked the path so that it's spreading along it. So this now allows me to have a bit more control in the fact that with the path deform on there, spreading out along a path, that it's going to allow me to be able to deal with this stretching problem. A stretching problem is going to be taken into account that I've got the path in here that's being spread along, and here's the, let's turn off my normalized spline first so you can see what's going on. What I have is a line, and I've got very few points along it. I want just a couple of points to control with the flex and get it to flex and bend up and down and whatnot. The less the better. The faster it's going to react, and it's going to be easier to control. But what you'll notice is as I move this up and down, you'll notice that in areas like here right now, as I do that, if you watch that spot right there, you'll see that it is doing that accordion action, and that's because the spline, its length and the way the spline, path deform is working is it's based on the length of each segment essentially, and not the overall spline. So you can see it's actually stretching it all over the place. If a Bezier handle runs, you'll see that it's going to make a real mess of it and stretch it all over the place, and that's exactly what we're trying to avoid. So what we do is we add a normalized spline modifier. We drop that on top, and we normalize it, and we set it up so that we have points that are being constantly recalculated. Now you'll see that when I grab any given point and do the same thing, I'm not getting that accordion action happening because the spline is being rebuilt on the fly. Now the problem we're going to run into, when you solve one problem, you generally create another, is that unlike the bone system that was stretchy, that we could have set up as stretchy, this isn't going to stretch. So if the line gets longer or shorter as it stretches, you're going to see that the actual tubing is pulling away from the rest of the model. We're going to have to overcome that. And that won't be a big deal because we actually have a stretch factor. And right now it's set up as 1. I didn't want to stretch the tubing to make it fit. I wanted to model it so it fit properly. And I'm going to use that stretch factor now, and I can work with this and drive this through some script controllers based on the length of the spline, and I can calculate that and have that keep its length correctly over the as it bends and flexes, and it does a little bit of stretching as it bends and flexes. So that's going to help a lot. So I've got that same system built in a couple places. Now, of course, building it with just a straight model and path deforming it was even easier than trying to model it in place and collapse it down to an editable poly, because now I can just draw a spline path to form it into place, and away I go. The rigger can now work with it. So we've got a few problems we have to overcome in this rig, and so in the next steps in this process, in this tutorial, we're going to address how we're going to deal with these and how we're going to get this rig to come together and actually work properly. To get started on this rig now, what we're going to have to do is we're going to have to determine how we're going to drive it. The best way to think about rigs is layering them and having layers of control. One thing drives another, drives another. For instance, one of the fundamental rules I always stick by is layering your model on top of a rig. Never rig the model. Here's just a good case in point. For setting up a piston system like this, it's very easy to say, well, I'm just going to use look-at constraints and make the parts look at each other and link them together, and I'll just rig the actual pieces here. There's a problem with this in that if you suddenly decide you need to swap one of the pieces out or change the model, or it's a temporary piece for a model, as you replace it, you're now replacing your rig and you have to re-rig it. So it's best to build a rig and link and skin the parts of your mesh to your rig. Again, consider that a layer. Well, with the rig, we can look at layers as well. As we piece it together, we can think about layering control levels one on top of another. For instance, we have a problem where we don't have a standard knee joint here, and there's no way we're going to get it work with a standard knee joint. If we try and put an IK system in where we run a bone from here out to this piece here, through this with 4 joints, down to our planer, and then down to the what we'll call the ankle down here, this flexible piece at the bottom. There's no way this system will work with an IK solved joint. It'll be all over the place. It won't be controllable. We won't get the kind of rotations where we need them. It'll just be a mess. So what we need to do is we need to think about it in layers. Really, we want that standard, very simple 2-bone leg system because it's the easiest to control when it comes to controlling an up and down motion in a character. So what we are going to do actually is we are going to start with that, but we're going to use it as a layer of control to begin with. So again, I'm going to create system IK bones, and I think these probably need to be, oops, I just made something by mistake, sorry. Create system bones, and I didn't hit 1 and 1, so that should give us bones about the right size. So now what I'm going to do is I'm going to basically take one, we'll just line them up in a second, and give us the basic leg joint here. Okay, so what we want to do then is we want to make sure that we have it lined up to our pivot point here. So I'm just going to use the align tool and make sure that it's lined up dead center, and then I'm going to rotate it in view space until I get that ankle in about the right spot. Now we might want to go turn wireframe on, and I want to get that ankle joint probably about the middle there. I'm just going to deal with one joint in there. I'm not going to get fancy with this. This is actually going to be a bit of a limited system that I'm going to create, but you'll get the idea. So into bone tools, under the animation menu, edit bones, and now I can change the length of some of these, and we're just going to use page up, page down, wherever it might be. There it is on this laptop. Sorry, I'm on one of Autodesk laptops here. So I'm going to set that about the right spot, and it looks like I bent the whole thing sideways somehow. There we go. I was grabbing the wrong axis. I'm in a local axis now. And page down. And put this in about the middle. And that should be pretty good. So what we can do now is we can actually use this joint, and I've made sure it stayed very nice and straight. The bones didn't get twisted or anything. That's very key. And I'm just going to color code this a bright red as our driving joint. And we're going to use this as our sort of master driver, so that when we grab the top of the character, we move it up and down, that we're going to get a typical IK solved system here. What we'll do is we'll drive all of the parts of the leg off of this so that it actually has the control that we're looking for. This is just going to give us the overall sort of bending action, and then we can use all the joint angles to be able to drive the pieces that we need. So the next step is going to be just adding a solver in here and getting it set up. First, what I want to do is I want to actually put something at the top of the parent here. So in Maya it's called grouping, and in Max grouping is something completely different. Essentially what you always want to do is you want to have something that terminates joints and objects, control objects, basically a parent object that is aligned in position and orientation to it. Now what I have is mgroup, which you can get off my website, and mgroup allows me to be able to easily create objects in a hierarchy. So I have the top joint picked here, call it the thigh bone, the driver thigh bone. I'm going to create a point helper and align to local, group each object is on, and a show point helper, and the size is going to be 4, I think. I want to say group. And what it's just done now is you'll actually notice that if I push page up, it's actually put it into the hierarchy. If I had all of the bones picked and did that, I'd get a point helper in the middle of each one, and they'd all be in the middle of the hierarchies. So next thing I'm just going to do is just make sure that as we move this around, I didn't take this out of its orientation with its parent. So I'm just going to align it, not in position, but in orientation, so that it's nicely aligned. You could have also just deleted the nub bone on the end and remade it using the bone tools. It's another way of doing it. So now that we have this, what we need to do is set this up as a driving system. So we can actually set this up with an IK solver, and then we can start working with it from there. I'm actually going to make this point helper a little bit larger, and I'm going to freeze off the geo for a second. Freeze, so I don't have to accidentally pick it. Let's make this much larger, because this is going to be our, let's say 8. That's going to be our very top of our leg. So let's make it huge. Let's make it 10, just so we know where it is. Okay. I'm also going to color it red, the same as the bones, so I know what part of the hierarchy it's in, and it'll control it. So I'm going to select my first bone, and animation, IK solvers, high solver, run that down to the bottom. So now what we have is the pretty typical setup for a leg of a thigh, and it's just going to do that. And what we're going to do is we're going to drive everything off there. We're going to need some control objects now. Excuse me. And those control objects can be simple spline objects. I'd usually use my pen control objects, but my installer hasn't worked on this box because I don't have mid rights on it. So I don't have those installed. So I'll just use some standard bits of splines, circles, and whatnot. And I'm going to grab one here and align it up to the knee. This is going to be the target for the knee. If you notice, I'm doing it in orientation as well. And in local, I'm then going to move it straight out from the knee so it stays aligned to the knee. And I want to make sure that I set the target, set the target, the swivel angle, the pick target, so that now when I move this side to side, it deals with the entire leg system side to side. So that should be pretty good. You know what might be a better idea here, just so we can see it? I'll say rig, properties, and we'll say see-through, backface colon as well. Oops, that was the rig. I didn't mean to do that. See-through. I meant to do that to the geo, sorry. Object properties, see-through. So now it might be a little bit easier to see what we're doing in some respects. So now what we've got is the control over the knee and the foot, and just temporarily for now I'm going to link the solver down to our control at the base, so that when we move it, moves the whole thing around. Now realistically, the pivot point for your control should be at your ankle, so I'm going to move it, effect pivot only, and again I'm just going to use that. I don't want the orientation on this time, I just want it lined up. And so now I can move my leg around. So this is the basic driver that's going to drive everything. Now we have to consider how we're going to drive the other parts and how we're going to build pieces for the other parts so that we can actually drive them properly. This is going to be a flex piece. This will be skinned, and down here we're going to have a harder joint. And down at the bottom we're going to have a soft joint. I'm not even going to think about the foot for the moment. We might deal with that later if we have time in this master class. It's more about how to deal with sort of layered rigs. So the problem with the way this is going to work is I could run bones all the way down and all the way down to the bottom, but this bottom joint here, this planar joint, is the one that's going to cause the problem. It's the one that's going to be very interesting to deal with at first. So the best way to actually deal with this is to leave it as an animation control for the animator. It's strictly a manual input. You don't want to automate everything. If you take control away from animators and they can't pose the character the way they need to, they're not going to be happy. So really what you want to do is you want to leave as many manual controls as possible, but you want to make sure that this foot will stick to the ground and that when the body's moved, the foot doesn't swim around or move around or something really odd happen to it, that it bends as naturally as possible, but then there's lots of override controls for the animators to be able to shape it the way they need. So what we're actually going to do in this system is we're going to have a bone chain that runs down that's going to flex automatically based on an angle of the thigh and the knee joint. But then we're also going to have a joint that goes up from this planar angle, and it's going to allow us to be able to rotate this and actually rotate this sort of, call it knee joint, back and forth. And then you're going to have the typical joints or controls down for the foot. So layering this next step is going to be the trick to get it to be to work nicely with this driving joint system. So we'll step into that in the next portion. Now let's put in a couple of joints that are going to help us deform this upper piece. So once again, we're going to go to Create System Bones. And I'm going to run one from the top here. Now one of the things with Max is that it wants to try and link stuff up. If you notice, if I try and click that on, it actually is trying to link itself to another bone automatically. And that becomes a bit of a problem. So I'm just going to, for now, I'm just going to build it off to the side, and then we can put it in place. So once I've got it, I can then add them where I want. I'll just move that one into place as we go. I think we want to go down to this bottom piece. No, maybe not. I think we want to stop here. This is going to be a solid joint here. This really shouldn't bend into form. It kind of bends from here. It bends from there. But this joint here isn't going to bend, so I'm just going to stop it there for now. And that's one of those things where it's going to take some playing around to get it right and get it working the way you want. I want to line this one up with the other one just in the side view for sake of argument. It probably it'd probably be the best bet if I line it up with it. And so again, I can use my align tools. I can line it up, but instead of lining it up in X, Y, and Z, you can pick and choose which you're going to line it in. Turn off Z there, and now it's going to line out to the just straight, keep it aligned. So I know if I move it side to side, it's going to end up in the right place. I'm going to turn off bone edit mode again. I want to move it over. And I want to try and align this just by rotating it. And first I'm going to do it in a view, and then maybe a local. Get it set down into the call that knee joint. Looks like it needs to be over a bit more. Keep them in the center as much as possible. Now it looks like it needs to get rotated down a bit more. Sometimes it can be hard to rotate something that subtle. So what I find is if you just use the type in and just tap the spinner, you can get it to rotate a little more subtly for you so that it can be lined up the way you want it. You need to go that way and back. So you want to be pretty careful to make sure you get things lined up exactly the way you want before you go on. So now that we have that one put in, once again, let's terminate the end with some sort of control, and then so I want to say group that. And for now, although it's probably going to change, I'm just going to parent it into the top of the hierarchy so I know it's part of the top of the hierarchy. And I'm also going to grab all of these joints just for now. I want to make them bright blue. Here's something else I tend to do to make my life a little bit easier. I color code things as I'm working on a side or figuring something out. generally when I'm finished, I have scripts that run over it and color everything to, left and right, green and red for port and starboard, just to so that I know the animators know and whoever's working with it from that point what's the left and right side rig pieces. But I tend to like working with very specific colors as I'm building it so I can visually see what I'm looking at and working with as I go. So there is the upper piece. Now what we want is we want a joint that's going to come down or up from this lower section here. So again, create system, and we're just going to stick it up anywhere. It really doesn't matter where this one goes up. It's not going to be skinned anything. I'm going to select though, and again we want to align. And I can't align to anything because right now I got everything frozen. Sorry, I just need to go in and say unfreeze for a second. And just make sure I pick the right item there. Looks like I did. And that's pretty good. And we want to have it in the center. That's good enough, I guess, for now. Let's just freeze the geo back off so we're not picking it by mistake. So this piece, I'll set to another color. Just a bright orange or something so we can see it. And essentially this piece is going to get rotated. And when we rotate this, it's going to bend and flex the blue joint, not affect the rest of the leg. It's not going to affect how the foot sits on the ground. It's not going to affect the lower ankle. It's just going to allow that planar joint to be able to be rotated. So again, let's terminate it, and I'll say group, and let's just make sure we give it the same yellowy gold color. So again, we know what we're looking at. And we really should get a control object put in there as well so that we can start working with it. So let's just start with a circle. Wrong angle here. And I'm just going to do an align again. All axes and rotation as well. Let's set that up larger. And let's put it into the hierarchy. So it gets put down into the hierarchy. So the top of this little hierarchy is the point helper, and everything's terminated and sort of frozen in its transforms already. Excuse me. But now what we want to do is we want to freeze transforms always on items like this once they're linked in. And since it's linked in, we should be able to freeze transforms on it so that we know we have that frozen transform for animation time. And we've frozen transforms on our controls all around. If we change the parenting at any point in time, freeze transforms again. So now what we want to do is we want to add an IK solver again, and this time we're going to run it just down through this portion of the leg here. And this is where I went a little bit further with this, and I actually had individual controls with all kinds of point helpers, and it was much more complex. But we don't have time to get into that in this tutorial. Also, it would go on for several hours. So now what we want to do is again, animation, high solver, down to the end. Now this will flex. We can then link this piece into the nub bone in the end, and you can see now that what I have is the ability to rotate and flex that knee joint back and forth a little bit. And if you can imagine, there's not going to be a whole lot of room for that to be bending in the first place. However, when we rotate this back and forth, really this joint should probably rotate up and down as well. So we're going to have to connect that in at some point so that it drives up and down. So again, layers of control going back and forth. So just to get this lower part, it's already proving to be fairly complex in its setup. Next thing we need to do is we need to address some of the other parts. So now we need to be able to drive. Let's just concentrate first off on the main body of the character going up and down. And we need to be able to drive some of this and have it work up and down and have it react as we'd expect it to, and twist side to side and everything else. So realistically, our lower control needs to be going down to our calf bone, our driving calf bone. So we can test that. We can think about it. So it all moves and it stays all nice and planar, and the only flex that's happening will be at this soft joint at the bottom. So you can see how that's working now. Now we might want to even try linking to our calf joint from the top of our driven blue joint and to see what we get there. A little bit better action again. So you can see a little bit of playing around, trying different hierarchies, and also we're getting a nicer bend in that joint, that blue joint now, working as we'd expect it to. What we want to do now is work a little bit on driving this one better, so that when we offset this, it offsets this blue joint a bit better. So again, freeze transforms. List controllers are your friend. Basically, you can layer up all kinds of layers of control. So what I want to do is I want to drive it. So I've got my Z-axis side to side, so that when this rotates, I want to be able to rotate the blue control here. So let's go and grab param wire again. So simple Alt-5 to open it up. Consider the driver. The driver is going to be our animation control down at the bottom, and it's going to be its rotation around its zeroed out Z. And the one we're going to drive at the top is going to be the same thing. It's going to be the one that's zeroed out Z in the rotation. And we're just going to say connect for the moment and see what happens. So you can see it's going back and forth. And it may not be exactly what we want. This is going to be a tough one to set up and get it to work right. We may even want to try and use Reaction Manager for it. But something else we can try is an ABS solution. That's absolute. I'm just going to say OK. And what that's going to do is mean it's always going to rotate in one direction, no matter whether I go positive or negative. I think I always want it rotating down. So let's go and actually invert the entire solution. And you can see we're getting a little bit better solution. Now again, this might be a job for Reaction Manager, where we might want to actually use Reaction Manager to sort of ramp in and out the value and play with it. How much should it move at any given point in rotation? And that can help a lot. And this is one of the few places I would use a Reaction Manager. But for now, we're going to live with what we've got there, and we can go back and replace it. We find it's not actually working as well as we'd like. So again, we're flexing nicely here. It's got a pretty good solution. If we pick up the bottom, it should obviously give us the same sort of solution. It's bending that knee joint quite nicely. I see that it's actually starting to push it up. And let's just do a little quick piece of animation here. Just go along 10 frames. And I'll lift the foot up. Just pull the target out in front so it stays targeted. And see what we get. So you see it looks okay, but what's happening now is when we flex this a whole lot, you can see what it's doing is it's pushing the blue joint backwards. It's actually, again, changing this up and flexing this up backwards. That can be a bit problematic in itself. So again, also when we go down low, it's not rotating down enough when we straighten the leg, and it's not rotating up enough when we flex the leg. We flex it up. So what we want to do is we want to do a little bit of extra driving on this to see if we can get it to work a bit better. Here's again one of those layers, and where you have to think about how are you going to drive it. If we drive the rotation of our blue slave bone to our red master thigh here, what you're going to find is that the rotation of this is compared to its parent, and really it's not that rotation we're looking for, because if I rotate out this joint and keep it flat, you'll see that it's the same solution. It's going to run the same problems in certain spots. Let me just go up to the frame here. I can straighten it out. And it's fine when it's up. So if I actually straighten the leg back out while the thigh bone's up, this joint isn't causing the problem anymore. So it isn't the rotation between this and its parent. It's the angle of the triangle. So let's take a look at that triangle. The triangle I'm talking about, let's find a color that'll show up real good, is basically the solving triangle of our solver. So it's this angle in here that is the thing that we have to actually be concerned with. So it's this angle across here that we're looking for. We're actually want to be able to track. So how do we track that when we don't have anything that's fixed on that point? So what we can do is we can, again, add another layer that we can actually use as a way to control that and get values from it. So again, let me just do a clear on my drawing tool. And we are going to add a new point helper. And I'm just going to say create helpers point. And I'm going to set it up, turn off the cross, put on the axis tripod. I have certain sort of combinations I use when I'm doing things. And I'm going to align it up to the top. I'm going to link it to the top. And then what I'm going to do is I'm going to put a look at constraint on it. I'm going to make it look back down at our foot here. So animation constraints, look at, pop it down and have it look at our foot. This is going to give us quite an interesting solution right off the bat, the way it's going to work. The other thing I'm going to do is I'm going to set up the up node to be the knee. You'll see that I have a similar solution, but it's not spot on. Let's see what happens if we turn on keep initial offset. There we go. We've got the same solution as the top of the leg. So what happens now when I lift is I can actually calculate that angle based on the difference between this joint here and our new point helper, our green point helper. So I can pull that up. And because I even use the same target, it's not using its up vector right now. Set look at, no, we need to play around with some of the values here. I'll do that in a second. And we should be able to twist with our up node. Maybe the keep initial offset is stopping it. No, keep initial offset's not. So let's play with some of these values. I have the feeling as soon as we do this, it's going to complain and jump all over the place anyways. Yeah, so keep initial offset's not going to help me. So let's get it so that we can set it up so that it'll actually work with that up vector. Circle source align to up node, and for some reason it doesn't want to do it. I'm just going to make my screen a little wider here and keep playing with values until I get it. So the look at's the right one down the X. New line center look at up node. There we go. Sorry, look at up node, and I've got it aligned back correctly. There we go. But I think our keep initial offset. Ooh, flick it back on. Look at that. How about it worked? There we go. So we're good. So we're back all nicely aligned now. So you can see that it keeps its up node correctly as well. The one other thing I like to turn on or off is view length absolute, or I tend to just turn off the view line. So we'll leave that on for the purposes of this tutorial, so it's easier to see. So now when I move it, our knee target, it's swiveling the whole thing. So basically what it means is we're not getting any value change between the thigh, the driving thigh, and our look at object. If I lift the foot, I can get a value change between the two, and you can see that the value change between the thigh bone of the driving leg, the red thigh bone, and that green look at object is changing, giving us that angle value back. So the next step there to get that angle value is to be able to go in and create another helper, and this time an exposed transform helper, and these are your friend. These things are very handy. I asked for them to get put into Max a long time ago, and they got put in. And they have saved a whole lot of time in Max scripts and being able to extract values. It doesn't really matter where they are in the scene. It doesn't really matter even if they're linked in. It just matters that they're there somewhere and you can tie into them. What I have a tendency to do is I always have a tendency to sort of parent them up one from what I'm going to expose. And in this case, what the exposed transform does is it exposes the rotation of an object. So if you notice right now, I'm exposing the rotation of the thigh bone. And when I lift it up, what it's doing is it's feeding back to me those rotation values, the local Euler angles of that thigh bone. Now, I don't want them compared to the parent, and that's what it's doing right now. Local reference node is the parent. What I want them compared to is our green point helper that has got the look at constraint on it. So that one there is going to give us a far better solution. So if you notice, it's not quite 0 for some reason. And you can see that it's a little bit off, and really, we really want that to be 0. So it looks like the keep initial offset hasn't worked very well. So what I'm going to do is I'm going to turn it off, and you're going to see how I'm going to do it now. So this object wasn't getting us our 0 because we want these values, these local Eulers, to be 0, 0, 0 when we're done. So it looks like it had a little bit of jump to it when we played around with the settings. So an easy, again, way to do that, create another point helper. So another point helper. I'm just going to leave this as a box. I'm just going to align this up to the top of our thigh bone. I guess I can make sure it's the top of the thigh bone. And I'm going to link it to our look at object so that it now just rotates with the look at object. And we can use it as our reference point. And we get 0, 0, 0. So a great way to zero it out. It's just, again, adding more layers of control. So now that this exposed transform is actually giving us an angle value, and if you notice, it's only happening on the Z now, because we're rotating around that Z, because both of them are staying aligned and pointed at the same target object. We can use this value now to drive our thigh bone, our blue thigh bone, or our slave drive bone, a little more if we want. So again, let's go and try it with a wire parameter to start with. Again, Reaction Manager is the last thing I always go to because it's much slower to calculate. So Alt-5 to get our wire params up. And the driving object, this case, is going to be the exposed transform. And there's our local Euler Z. And the object we're going to be driving is going to be this bone. Now let's just inspect this for a minute before we go any further. You'll notice that what we've done is if we've wired that Z rotation into the control at the bottom, that rotation control. If I try and wire again to this, I'm just going to override the original and it's not going to be there. This is the beauty of list controllers. We can add a new list. We could actually add a list here and build the list right there, or we could build the list in this available track. And so let's actually go and build it just in the available track, a whole new one. So I'm going to say assign controller Euler XYZ. Let's go and grab the new Z, and we're going to drive it. So when I load this bone up over here, it's actually this new one. And again, we could actually go in and you could properties and name them. And we could say, well, let's actually name what this is. Planar ankle. And this one is going to be the thigh. So we can actually see its name now and know what we're connecting up to. So let's just say connect. And then let's see what we get when we actually lift this control up. And you can see it's actually driving it further. But again, as I said, the nice part is, let's drive it right up, is that it's based on the actual angle of that joint, the angle of the IK solve. So we can drive it up and down a little bit more. So now it's a matter of just finding that sort of happy value, 0.2 update. So I'm multiplying the value by 0.2 and seeing how it works. And you can see now it's working a little bit better, maybe a bit more. Let's try 0.3. And I can just play with some values here. Straighten it out, and it goes down a fair bit. Let's try, oops, I didn't put 0.3, sorry, 0.3 update. Must have missed it. That's working pretty good now. Maybe we can go 0.4 and see what happens there. I'd say that's even better. So we're getting a really nice flex there. We're not getting any sort of over rotation anywhere that we don't want it at this point. So you can see that layering up some controls will get you a much better result overall because you've got more control. So we'll continue and try and get the rest of the pieces put together and working properly. Now let's have another look at the control at the ankle, at that planar ankle joint, where I was saying it doesn't work perfectly. If you notice what's happening, as it starts to rotate, we're driving this top bone, and you'll see that it's actually starting to bend backwards, and it doesn't work quite right with that simple expression we used. So let's again open up our pram wire and just reload the tracks. So the one that's being driven is this top bone. So let's go and get it, and it is that planar, and then we can reload on the other side, the one it's connected to, using our little spy glasses here, and we find that connection. So really this isn't working. It isn't working the way we'd like it to. So I'm just going to say disconnect, and it no longer functions. Now let's try it with the Reaction Manager and see what we can do with the Reaction Manager. So again, Animation, Reaction Manager, we bring up in the Reaction Manager dialog. Reaction Manager needs to be dealt with very carefully. It has a fair bit of complexity in the way that it works. And the issue being is that what can happen is that you can make a mess of it. If there's any odd entries in here, clear them out and make sure you work with it very cleanly. Don't just keep adding them, adding connections and whatnot. So what we need first to load is that driver. So that's that first driver at the bottom. So I'm going to pick the Create Master, I think they call it here. And we're going to go to Rotation Z. So there's our master rotation along the Z axis that we were dealing with. Now we want to add a slave, and that was our bone up top here. So I'm going to go to the Add Slave, and again it's that same, it's the thigh, or sorry, the planar ankle Z rotation, and it automatically sets up a state for us, which is 0. Essentially the input value is 0, and the starting rotation value is 0. So we can change that if you want. You can actually scrub this up and down. You can see the bone rotating, and it's not what we want. We want to leave it as 0. And what we can do now is we can actually set up a few animation points. This is the way I tend to do it, is just animate a couple of the points along the way. I'm going to rotate frame 10, turn on animation, grab our main control, and we'll just rotate it back. Maybe we want to go back about, let's see if we can get back that far, somewhere there. And we're going to go forward, and we'll rotate it forward, and we'll see what we can do about getting it to maybe about there somewhere. And this is going to be a little bit of playing around. So what we can do now is we can set it up so that we can input the value directly. And essentially what we can do is we can grab and create and rotate our parts. Now we want to be a little bit careful that we have the correct controller active when we're doing this. We want to know that we actually have the Reaction Manager controller being active. So again, back to our dope sheet, and we'll take a look at that bone. So we've got our thigh rotation, and our frozen rotation, and our planar rotation, and this one's the one that should be active. So let's just right click on the rotation and make sure it is. It is indeed. This way, if we actually try and rotate it into place using the Reaction Manager tools, that we're actually going to be rotating the correct layer of control and not the one above it. Because if we had the one above it, you'd never get a change, and you'd be wondering why. And it's because you're not rotating the correct controller. So that is correct. It's certainly working fine there. So what we can do now is we can go in and we can say, let's create a new reaction, and say create state. Go to edit mode, and then you can just edit it and rotate it into place. Let's see the result. You have to turn off edit mode. You can see now that it rotates with it. It rotates at good speed. Let's go the other way. Let's create a new state. Edit mode again. And you'll see that it's way too far. There's no way it's going to reach that solver at the end. So that's probably a bad one to try and set up. So let's actually go and just adjust this frame solution so it's a little more plausible. Edit mode again, and try that. Turn it off. And it doesn't look like it edited it properly or something. I think probably our state's incorrect. Yeah, our state value, sorry, has been changed. Set state. There we go. So there's setting our state. Because we changed the state, we needed to set the state back to what it's supposed to be now. And it looks like we should have a good result now. And now what's nice about this, if it doesn't rotate at sort of the right speeds, you can see it spots where it starts bending the other way. We can go and adjust and play with the function curve in here and get it to work exactly the way we want. So you can actually go in and grab it and, for instance, set it to Bezier smooth, and you're going to get a different result on the solution. And you can start playing around with that solution to see what's going to happen to it. So you can adjust it, play with it, ease it in, ease it out, whatever might be needed to make it look like it's doing what it's supposed to do. So we can even try and ease in, ease out there. I think it just made it worse doing that. Let's try and push them up. And again, it's a matter of playing around with it to get the kind of solution you're looking for. Let's assume that's good enough and move on. So essentially that's working pretty good now. And the only problem with the Reaction Manager is it is really based on how far it works to. So you can see it stops working at a point. Quite frankly, there's going to be a point that the animator shouldn't be going to anyways, and it doesn't make sense. So try and solve as much as possible. Don't overcomplicate it, and keep it within range of what's going to be able to be used. Now, that being said, is if we go and take this foot now and lift it, we may have more range to deal with. And so we'd have to make sure it tries to work for both cases. Now again, this is one of those things where it's not going to work really well. I mean, it's going to look pretty strange. Besides, the way I've modeled this, it's not even going to be able to bend this far up anyways, because this piston here is going to get collapsed all the way, and the foot's not going to be lifted that far off the ground. So again, we have to consider what we're rigging. Are we trying to rig something that's simply not possible based on the model? I've often seen people with shoulder joints and characters, and they rig it and they keep playing with it to make sure that the forearm or the upper arm can rotate straight up from the clavicle. Well, we can't do that, and it's not possible. You break your shoulder, so why try and rig it so it can do it? You know, maybe it's a cartoon character and you really need it, but generally you're not going to, so don't bother. So now we've got a solution that's working pretty good with these extra drivers going. What we'll do is we'll just get off the animation mode there, and we will back into our left viewport, and we could apply and build a foot joint here. This tutorial is going to go on too long. It's a pretty standard foot tutorial, so we'll just do a really simple bone maybe on it or whatever, and go from there. But we won't worry about the bending and flexing of the foot at this point. The main point of this was being able to layer and use your different systems for actually being able to drive something that's complex like this and getting it to work. So the next step really in this tutorial that we're going to get into is rigging up the hoses and the piston here to have that working. Okay, so for the third overall portion of this, we'll get into rigging up the extra bits. First, we'll start with the piston system. This is pretty easy. You've probably seen it all over the place, but I'll set it up anyways. And just a note, I did a really quick setup on the foot. I put a bunch of one bone solvers in for each joint all the way down. I added some point helpers with some orientation constraints to a new control, so each of those point helpers rotates a little bit more than the last, and they're all linked up down to the, if I push page up here, you'll see it picks the, sorry, if I push page up, it should be anyways. I have a hard time working with the Camtasia going. It seems to foul things. There we go. Let's try that again. I should be able to pick that and push page up. There we go, and it picks the foot. And page up again, it picks the foot. So they're all linked into the foot control. But when I rotate this control, you'll see it bends the foot bones. And each of the solvers is linked up to a different layer of rotation, essentially, through the constraints that I set up. So you can tear that apart and figure it out. It's pretty straightforward. So now the next piece is going to be working with our piston here. Again, I don't like rigging the actual geometry, although in this case it would be very easy to do. What's nice is if you actually do it set up with helper objects and bones and whatnot, and you need more pistons, it's very easy to copy the entire system that you've generated and stick it somewhere else and it still functions, instead of having to re-rig the system onto the geometry again. So again, let's just line this up. What we're going to do is we're just going to use some point helpers again here. So create helpers, and we're going to go with a point. And I'm going to throw on the axis tripod again. And let's just open up our layer managers and unfreeze. So I can do some aligns here, align orientationally. And I'll just make a copy. And I'll say align orientation. Oops. Not what I wanted. Align in orientation for the copy. Oh, looks like I got both of them. One of them picked. Okay, I'm going to try that again. There we go. And really what you need is 3 point helpers. So I'll make another copy again here. And we'll just make this one smaller. So the way this is going to work is that they're going to look back and forth at each other for all intents and purposes. And this is going to be the root of the bottom. So I'm going to link this one into our root down here. Let me just freeze off the geometry again. That should be the root now. Let's confirm that. Yep. And the top doesn't have one, but it's going to get linked into our bone system so that it's actually being driven by our bones. And the bottom one is going to get linked into our bones as well. We'll link it down to this bone at the bottom here. And now we have a system we can set up. So what's going to happen is the bottom of the larger of the bottom control is going to look up to the top one. So again, so let's set up animation constraints. Look at constraint. It's going to look at the top, and it's going to use our bottom, our main. Can't make circular dependency. Why can't you? I must have picked itself. There we go. And let's make sure it stays aligned up to its source Y. There we go. I like things being aligned. And although our X is down, let's flip it. And so that's not quite right. Flip it. There we go. I like things to stay aligned to each other and not just be arbitrary. So if I'd flipped those around, that would have been fine, but you know, I want them both flipped around. So now again, the top is going to look back down to our small bottom one here. And so same thing, it's going to go and look down to the bottom one. And let's make sure it's got the same settings. I should say actually view line absolute. And let's set its look at. And that looks pretty good. I might just set the view line absolute here. So now they actually collapse together. So when it lifts, you'll actually see them sliding and looking at each other. It's going to be really simple to rig that a piece of geometry now, because all we need to do at this point is simply take the correct pieces and link them up. And we have a piston that works. So you can see that it's actually sliding up and down as it's supposed to. So pistons are very easy to set up. So you can see we don't have a huge range of motion anyways because of the limited range of motion of that piston. Let's just, while we're here, let's just link that one in as well. There we go. So there's our piston working. So it's just a couple of look at constraints. So that was that's quite simple. Where it's going to get more difficult is when we start getting into these tubes. We'll do that in the next section. So now we go about setting up the tube to stretch and to flex properly. One of the things to note right off the bat is we need to link both into the system, and probably one of the best things to do is play around a bit, but one of the middle bones here would be the best choice, something close to its the middle of its overall rotations. What this will get us now is ones it'll actually move with it. We really want to make sure it does it, even though we're going to be using the spline IK modifier to pull the spline around. We want the transform matrix of both the tube and the spline to be changing correctly and to moving with the rig. If you're just pulling the spline around, what you'll get is you'll get an up vector problem with basically along the length of the spline. The tube will spin out of control, and there's nothing you can really do to stop it. So next thing what we're going to do is we're going to just set up the spline itself so that it functions correctly and does what it's supposed to. I'm just going to turn off the spline normalized spline modifier for a minute. And what we're going to do is we're going to go down to the spline. And one of the things I find best is to get rid of the spline handles and try not to use them when you're modeling it. The reason being is when we use the spline IK modifier, it will control the handles as well, and will tend to want to go and twist if you don't control it yourself. And you'll have to then sort of manage the rotation of each point helper to be able to stop the spline from doing strange curves. So if you can, avoid it. If you can't, well, you're just going to have to live with it and manage it yourself somehow. So I'm going to just try it with the middle two here, put them on smooth, and leave the end ones so that I keep a nice sort of straight out vector going, and work with that. Now what we're going to do is we're going to add the spline IK control, as it's called, say create helpers. We get our 4 helpers. I'll just size them down a little bit better. And now let's just link those into the needed bones. So one there, say one there, one there, and one there. Oops. One, this bone. There we go. And we should be able to get it bending and flexing now with the system. Now you'll notice that because I have 4 bones and 4 helpers, the middle's kind of getting stretched more than what we like, and we might want to find again to put point helpers in between these bones and orientation constrain them between the two and get an average rotation out of some of the spots and play with that to be able to find out how much pull we want to put on these point helpers. We'll work on that last. If it doesn't work up, we can change that up and change up the hierarchy there for how they get pulled around. So looks pretty good so far. And what we can do next is we can even play with the flex a little bit right now and get it working. So let's get it actually working. There's some tutorials on my website at penproductions.ca or paulneale.com that both have some tutorials on how to deal with flex. And I deal with one with a light bulb swinging, and it deals with the spline and how to set it up. So that might be able to help you more as well. But we'll go with modifiers animation flex. And the way flex works now is you're going to find that it's going to go and do some crazy bouncy stuff. Let's just crank up the amount of flex. And the flex is just designed to flex from a central point. And that central point is the center point here. And it'll change up sort of where the selection is. We don't want that. We don't want to work with that. So we're going to say use weights off. And we're not going to use that. I'm just going to turn the flex weight back to 1. We want to use chase springs on. That's always trying to sort of pull it back into shape. And we're going to use those. We're going to use those a lot. Next thing, we're going to go to edge vertices. What we're going to do is we're going to actually, when you pick an edge vert, what happens is it doesn't participate in the solution anymore. So you'll see that when I, again, let's just crank it up just to show it doing something. You'll see that the ones I picked aren't participating anymore and aren't flexing around. So we're going to pick a couple of the end. And if you notice, it isn't just the end vertex. If you pick down a little bit, you can actually find another one. It's actually the segments in the spline that you're picking, not the vertices or the handles with flex. So I want to grab a couple on each end to try and keep a good sort of straight vector going in and out on each end. And then I'm going to go down to weights and springs. And weights and springs allows you to basically be able to set up a spring system that'll try and hold the shape together and try and hold its length and everything. So I want to pick all of them at this point, and you'll see all the points along the spline picked. Now I was kind of careful too. I made sure my interpolation was set down to about 4, so I didn't get too many of them, too many points along them. And although it could be the handles, I think there's 4 there. So anyways, I want to pick them all, enable springs, options, and what I find, just turn it way down to start with. We're going to say hold shape springs, and I want to say add springs and just say show springs. You notice probably none have been selected. The reason I said turn it right down is because this maximum edge value isn't always correct when you first start. So I'm going to turn it up just a little bit past where they say the maximum edge length is right now, and just say OK, and then add springs. So you see we've got a bunch of springs added now, so it's kind of one between each. More springs you add, the sort of more finicky it will get. Too many, if there's too many connections between all of the points, it'll just pull itself apart. So 1 to 1 down will work fairly well, or you can have a little bit of overlap, and it'll tend to try and keep its shape better, but it might want to sort of blow up all of a sudden a little bit faster. So this should be sort of one spring between each control at this point, trying to hold it together. Something to note, always go with the suggested strength here to start with. So because we're using the shape, we're using the hold shape. Okay, we want to make sure that we go with the shape strength. So let's just go with 0.3 and 0.3 just to start with. And you'll notice now that when we scrub it, we get that springing action a little bit. And it looks like for some reason it's suddenly flipping on its side again. I had this happening earlier. I might want to take these 2 objects and link them down one more. Let's see what happens here. Oh, still wanting to rotate around at the end. Well, that's interesting. I wasn't doing that a minute ago. That could be to do with the handles. We've run into some oddities with just the handles. So let's see if that solves it. Whoops. Smooth. And you might, so in this case, you might want to add extra verts in there to make it work better. Let's see if that solves it. And it looks like it does. It's the handles that are making it spin around. Why, we don't know, but it seems to cause problems sometimes. So avoid the handles entirely, it looks like. So now that we have the flex on there, we can make some adjustments on it. So we can actually just hit play and see what it's going to do for our solution. I'm just going to turn on shaded view, and we can see what it's going to achieve. Now we've got 2 things kind of fighting each other. The shape strength and strength are kind of doing the same thing, except this strength is trying to pull it right back to its origin. This strength is trying to keep the edge lengths even. So if I actually turn down the strength here, you'll notice that the tube is now isn't any longer actually making the 2 center points, and that's because its length is being pulled straight more, and it's going to be running into the rest of our model as it starts to go. So we need some of that strength in there. So it's going to be a bit of a balance. What we can say in this case is let's pull down this strength, let's let it stretch, and let's pull up this strength. And what the strength does, it tries to pull it back into shape. The sway, if I turn that right down, basically it shouldn't be called sway, it should be called dampening. And you'll see it sort of bouncing all over the place now. So we could try this shape sway down here. I don't find it works as well. Okay, and what we need to do is play around and have it sort of spring and stop, and so it only goes a couple of times and it comes to a stop. So we can play around with that sway setting, which really should be called dampening again, and get it to sort of stop the motion a little bit. And maybe we want some more strength, pulling it taut. I find the flex value when you start doing this, when you start turning off use weights and everything else, pretty much want to leave it at 1. If you go over, it'll start doing sort of stranger things and sort of start doing some oddities. But you can play with it a little bit, so you can turn it down, whatnot, but don't try and crank it up. It's got to stay around those values, I find, and you can get some pretty good results. So we've got it springing around here. Try a little bit more strength to pull it back. And, we can play around with it all we want. Now, one of the best things to do is, and this is something that, to note, is that I have a lot of people say, well, the problem with Flex is that it doesn't give me the solution I want, and it's hard to control. Well, like any dynamic solution, you need to solve it for any given shot. So if the character suddenly leaps through the air, it'll tend to want to get left behind. Now, these shape springs will try and pull it back together and not allow that to happen, but it's going to go everywhere. So you may have to ramp it down. You may have to ramp off the flex amount and back up for those few frames to let it sort of, stop it from doing that. So it's a matter of controlling it. So we'll accept that. We'll say that's working pretty good. Now what we need to do is we need to deal with the actual shape on here, the tubing, because it's stretching and pulling away from the end. We need to get it to keep its length. So basically we want to drive this stretch value up and down so that it finds out the length of the spline and adjusts itself accordingly so that it stays fitted to it. So again, back into the dope sheet, and in the dope sheet I'm going to go in and grab space warps, stretch, assign a controller to it, float script, and we need to do a couple of things. One, we need to reference the spline directly, SPL. It's going to be our spline. And let me just go in and grab that spline directly. And it's going to be directly, I mean by actually the node. So we're going to assign it as a node, expand all these, and find that spline. There it is, selected. You can see it's selected there. And so that spline now directly, SPL now directly refers to the node. So now what we can do is we can just do a couple tests. Print curve length SPL. Pull the listener back in here. And you can see what the value it's giving us is 16.6076. Okay, so this is the actual current length. So I'm just going to grab that for a second and just put the listener out of the way here. And I'm going to create a new one, and it's going to be base length, create. And I'm just going to assign a constant to that. I could have just typed it right into the expression. I find this a little bit easier to deal with if it's by script. I want to control a whole pile of script controllers and some base value. I don't need to try and parse the script and find it and change the value in there, which would be very difficult if all the scripts are a little bit different. If I have something like a variable here called base length, then all I need to do is be able to access that base length value parameter and change it, and everything else follows suit. So I'm always thinking ahead in production. What may I have to fix later? What may I have to do en masse later with script? So now that that's working, what we want to do is we want to work out our values. So it's really simple. There's our bit of math. If I print that again, you'll see that it's a near value of 1, very, very close. And any stretching that happens is going up from there. So that's going to be our little bit of math right now to start with. And I'm just going to just comment out that for later. And now what you're going to find is it's going to stretch nicely. Now remember what I was saying about it not stretching evenly. We can see it stretching more or less in different spots because I turned off normalized spline. Let's just turn on normalized spline here. We can see it straighten itself out. And now that's better. It's not stretching more than I want it to. Now the normalized spline, it looks like it's causing it to flip. Well, I'll see if I can solve that in a minute. The normalized spline now has a problem on the end here, and that problem is that as new vertices are created, you can see them really close together, and it starts looping back on itself, and that can cause a problem. So really you want to add more points, and you want to get them really, really close, but the spline length only goes down to the bottom. to 1. So again, what we're going to do is we're just going to open up the listener, and we're going to say $, the current object, dot modifiers, first modifier, dot length equals 0.2, and we're going to lower it in MaxScript because the UI doesn't allow it to. So now you can see we've got more there, but the problem's still going to remain. It's going to hit that point. So let's just go and actually just go point, probably 0.1. If you can still see that. And we're going to shove the end of this back off the end of the spline a little bit, say 2, to the point where it isn't right on the end. It isn't actually right on the end. So if it's not right on the end, it doesn't get affected by that last little one as it gets created. And that will solve the problem a little bit, just so it's not right on it. So now we actually have the tubing keeping itself in its length as best as possible. Looks like my flex is probably still too high. Maybe I'll just try and take down the flex amount and work with it, because we just want a little bit subtle movement on it. So we can test that, and once we get some test animation going on the character, and the animators have done some walk cycles and whatnot, start playing around with the optimal values to start with. And again, for each shot, it just takes a little bit of tweaking. What I'd do is I'd usually wire up these parameters into some sort of UI, into a modifier, attribute holder modifier or something, so that they can be tweaked and played with a little bit easier at the animation level to get the final results the way we want. So now we have that tube working, and it's just a matter of doing that on all the other tubes and getting them to work correctly. So one of the things you want to do too with Flex is you want to turn it off during animation, because it is time-based. And the other thing is it's best bake the solutions using point cache when you're done finally, before you hit render, so that if you send it off to a network render farm and box 10 picks up a frame at frame 100, it doesn't have to calculate from 0 to 100 to get to the solution. It'll also get around any problems if they were popping, if one solution was slightly different than the other. Shouldn't be, but you could run into an issue in that case. So right now I think that's working pretty good. Looks like we've got let's see if it still flips around at any point. Doesn't look like it is. No, it looks like it's just as we were in the spline down below the one point in the spline. Oh, no, it is. It's actually spinning sideways at 1 frame for some reason. So we're going to have to try and find a solution for that. I think what's happening is what it's being linked to and how it's being pulled might be a bit of a problem. Let's see what if we go to a different bone here and see if it actually solves the problem. Again, we might have to put something else in there to control it. How about that? Just found a different bone, a little more aligned to it, I guess. I don't think it's going at any point. Doesn't look like it is. Doesn't look like it's popping or twisting sideways. So there you go. We have a tube that is rigged and working correctly. So all that really needs to happen from here is that we just need to go in and skin and link all the parts of the model up, and of course finish these tubes down at the bottom with the exact same solution, and we should be able to have a pretty cool looking rig going. The skinning's pretty easy. It's pretty straightforward, and the linking's pretty straightforward. So I'll leave that and just for the tutorial, and just produce an end result and show you how that is. So in conclusion for this rigging tutorial on technical rigging, what I've done is I've just completed the rig to a certain point anyways, very quickly, some quick skinning and whatnot. Just hit play here, and you can actually see it play back. Now I'm probably having a bit of a playback issue because of the Camtasia recording at the same time, so let's just turn off real time, and for some reason it's then not playing at all with Camtasia on. Huh. Okay, well, we won't do that. See if I can turn something else off to get it to work. Doesn't look like it is. Okay, we'll just forget it, but I'll hit play with it like this. And you can see that the flexi bits are flexing. Both tubes on the other sides are working. exactly the same setup as the large one that we did. They're trying to keep their shape as best as possible using the shape springs in flex. The piston here is moving up and down as it should. I actually reduced the amount that the foot lifted off the floor so that the piston didn't go way past where it's supposed to. Made a couple other little changes. Linked up the knee control down to the foot so it rotates when you lift the foot up. It rotates it. And of course, a couple little more setup things. We take a look down at the bottom. When I rotate the foot with a skin, you can see that the piece in the middle twists. Again, I did a really fast skin on that. And that works all pretty good. I did a really quick setup on the middle part of the foot, but it really probably could use something better because you can see that the foot slides as I rotate it up, and that really shouldn't be happening. It just means a little more sort of rigging going on in there as far as point helpers with some constraints, orientation constraints, and making sure that items are rotating around given pivot points as opposed to just sort of a little bit arbitrary right now. I just added a bunch of single bone solvers in the foot and linked it up to a single rotation control. Of course, there should probably be more heel rotation controls and toe rotation controls and whatnot, but the foot isn't that much different than any normal foot. So you can see that it twists at the bottom, and then it all keeps together. It all stays together. So we can actually take this rig and rotate it around a long way. Nothing flips, nothing goes out of whack, so you can actually go all the way around with it. And everything works as it should. And this is something you should do when you test your rigs. A lot of times I get people come to me and say, "Hey, it works. Look, look," and they do something like this. See, it works. And of course, as soon as you take the character and turn them around 180 degrees in the scene, everything blows up. So you have to make sure that you actually pay attention to how it's going to be used and spend some time working on the systems and making sure that they work in all the scenarios that are going to be needed. So right now it works quite nice. You can see that you can lift it and pull it and push it and whatever else, and it all works very nice. And it's simply not a typical rig, that's for sure, for a leg on a biped or something. But once you look at it in its layered form as layers of control for each thing, it's actually not all that complicated. Each step takes place and each one drives the next, and it actually works out quite well. So there's the final result. Hope you enjoyed the masterclass. And my name's Paul Neale, and you can visit me at pemproductions.ca or at paulneale.com. Take care. Bye.